Hey guys, this is video 16 on position, velocity, and acceleration, also known as PVA. So just some keywords to see. When you see them, you should think of this. Initially means that time is equal to 0. At rest means that the velocity is equal to 0. And at the origin means that the position is equal to 0. And you can remember that because origin is like where it is on the graph, right? So position is equal to 0. Okay, so velocity is positive, then you're moving right. So if you see the word move right or move up, you should think about how velocity is positive or greater than 0. If your velocity is negative, that means you're moving left. So if you see moving left or moving down, that means your velocity is less than 0, it's negative. If your acceleration is positive, that means you should be thinking about the velocity is increasing, right? Because if we were thinking about the acceleration sign chart, what came before it was velocity, right? In order for acceleration to be positive, that meant the velocity graph had to be increasing. So velocity is increasing, that means acceleration is positive. Velocity is decreasing, that means acceleration is negative. And then if you see the word speed, just remember that's the absolute value of velocity. So it's not going to be any negative numbers there. So speed increasing and decreasing, that's like you're speeding up and slowing down. So speeding up is when velocity and acceleration have the same sign. So if both velocity and acceleration are positive or both velocity and acceleration are negative, that would be you're speeding up. You're increasing. Your speed is increasing. Slowing down would be like when the velocity and is positive and the acceleration is negative, or the velocity is negative and the acceleration is positive. So they have opposite signs. And these are your justifications also. So if you're justifying why speed is decreasing or why the particle is slowing down, you want to say it's because velocity and acceleration have different signs. And you're going to show that one of them gave you a velocity function at a certain time that was positive, one gave you the acceleration was negative, or vice versa. Okay, so use these also as justifications, not just as when you see it, do this. Alright, so now a little bit for you to fill in here. So when you see find the average velocity and you're given the position. Now let's keep in mind that we have our position, then we have our velocity is the derivative of the position, and then the acceleration is the derivative of the velocity. So if I'm given position and I want to find the average velocity, that's just taking the derivative. So I'm going to say d dx to abbreviate here. So that means we're just going to find the average rate of change using the position function, because that's going to give me my average velocity. So my x of b minus x of a over b minus a, that's just our slope formula, right? Now, if I want to find the average acceleration, same thing, and I'm given v of t, acceleration is also the derivative of velocity. So I'm just taking the average rate of change of the velocity, which is just, again, slope, v of b minus v of a over b minus a. So this is just another derivative. The instantaneous velocity, when you see the instantaneous velocity, that means the velocity at that one point, right? So at that one point, I'm taking the derivative. The total distance traveled, that's your first integral on this chart. So if I want to find the total distance traveled, then I'm looking for the integral from a to b of the absolute value of v of t dt. So remember, if it's the absolute value, that means that if the curve goes under the x-axis, that means we need to find the integral for that area from whatever time this is, 0, we'll say, to time 1. And then we're going to find the integral, and we're going to subtract it because it's going to be negative. We're going to find the integral from time 1 to, we would say that's time 2, say. Okay, so you're going to be splitting up those integrals. If you're finding the total distance traveled, first you have to find the positive area, and then you have to find the negative area if there is a negative area, and then add them together because I'm going to find the total distance. Total distance means I'm adding, even if I walk backwards, I'm still adding how many steps I get, right? And then average velocity is also an integral. Average velocity, you should kind of think of it in terms of like average value, because average value works the same way. It's just the average value formula. It's 1 over b minus a times the integral from a to b of v of t dt. And remember, this one is different from the average velocity given x of t, because if I'm given x of t and I want velocity, I'm finding the derivative. It's just the next one down, right? But if I'm finding average velocity and I'm already given v of t, then I have to use the integral, because I'm going to have to find the integral with that average value formula. So that 1 over b minus a is going to work for that. So depending on which one you have, you use different formulas. Let's try some examples. Alright, this is the first example, the top left corner in your packet. The velocity of a bug moving along the y-axis is given by the equation v of t equals 2t minus 1 times t minus 5 squared. At what time, or times, on the interval 0 to 10 does the bug change directions? Give a reason for your answer. So what words do we see here that were on our when you see this, do this chart? So nothing is like super like in your face, like it's not saying when is it positive, when is it negative, but it does say when does the bug change directions. That means when does it go from right to left or left to right, which means I'm looking for when does velocity change from positive to negative, right? So when is the velocity changing sign? So if I'm looking for when the velocity is changing sign, maybe I'll make my sign chart, right, for my velocity graph. So my velocity, I need a critical point. So my critical point is when that velocity is going to be equal to 0. So if I set this equal to 0, then I have, this is going to be time equals 1/2, or time equals 5, right, because that's just the zero product property. But I'm also looking at the interval from 0 to 10. So both of those count. So from 0 to 1/2 I'm looking at, and from 1/2 to 5, and 5 to 10. So now let's see, if I plug in v of 1, or let's do v of 0. If I plug in v of 0, what is my sign going to be? Is it going to be positive or negative? So that's going to be a -1. Let me get rid of this. -1 times 0 minus 5 is -5 squared is positive 25. So this is going to be a negative number. Again, I don't care what number it is. I just care what sign it is. So between 1/2 and 5, now I can test v of 1. So v of 1 is going to be, that's 2 times 1 is 2, minus 1 is 1, and then 1 minus 5 is -4, but it's positive 16 because it's squared, which is going to be a positive number. And then at between 5 and 10, maybe I'll test 6. So 2 times 6 is 12, minus 1, that's a positive 11, times 6 minus 1, that's a positive 1. That's going to be a positive number. So when is the only time that it changed sign? It changed sign at 1/2, which means the bug changes direction at time equals 1/2. So let's write a sentence for that. The bug changes direction at time equals 1/2. And do I have units here? I don't see any units in this problem, because velocity changes sign. And there's your justification for it. Okay, so the bug changes direction at time equals 1/2 because velocity changes sign. Let's try another example. So in example 2, I'm going to go to the yo-yo example right next to it. A yo-yo is moving up and down a string, and the velocity of the yo-yo is given by the graph below. On what intervals does the yo-yo have a positive acceleration? So positive acceleration means what? What did that mean on my things you need to know chart? Positive acceleration means that velocity is increasing, and the velocity graph is graphed above. So I'm looking for when v of t is increasing. So I have v of t here, so it's increasing between 0 and 2, and then it starts decreasing between 6 and 8, it's increasing, and it stays constant. So the two intervals where it's increasing are between 0 and 2 and 6 and 8. And the reasoning, your justification, is because v of t is increasing. Hence, your acceleration is positive. Okay, so that's what's really helpful about using these v of t graphs. It's just kind of like an f prime graph, right? So if this is like f prime, in order for me to say when is f double prime positive, that would be when f prime is increasing, right? So it's the same exact thing as those f, f prime, f double prime graphs, but now we're just putting it into a context. In example 3, the bouncy ball problem, a bouncy ball is bouncing horizontally between two walls on the interval 0 to 5. The horizontal velocity of the ball is given by this equation. I want to know the maximum acceleration of the ball on the interval from 0 to 5. So you should be thinking, okay, maximum acceleration, that's my like absolute maximum, right? Because it doesn't say the word relative. So I'm thinking about finding the critical points of the acceleration and then substituting them back into the original acceleration function. I don't even have the acceleration function. So first I have to do that. I have to find a of t, which is just the derivative of velocity. So that's going to be 2t squared minus 8t plus 5. But I want to find the critical point so that I could plug it back into this function. So a prime of t is going to be equal to 4t minus 8. Set that equal to 0. So 4t minus 8 is equal to 0. That means my time is going to be equal to 2. So when a prime of t is 0, then time is equal to 2. That means that that's my critical point. So to find the maximum acceleration, I'm going to plug in a of 2 and see what is my acceleration at that critical point. So 4 times 2 is 8 minus 16 plus 5. That's going to be negative 11 plus 8, so negative 3. Now, when I'm testing for absolute max or min, I also have to test the critical points, right? So I know at the critical point, I have a of 2 equals negative 3, and I meant to say the endpoints I need to test at. So I have the critical points is that the acceleration is negative 3. At the endpoints now, the endpoints were at from 0 to 5. So a of 0, sorry, I have to go into the other box. A of 0 is going to be just 5, because everything else is going to cancel. And a of 5 is going to be 2 times 5 squared minus 8 times 5 plus 5, which is going to be 25 times 2 is 50 minus 40 plus 5, which is going to be 10 plus 5 is 15. So the maximum acceleration, I'm comparing these three, right? Those maximum acceleration is 15. So justifying my answer, the maximum acceleration is going to be 15, and there's no units in this problem, otherwise I'd have them on there. At time equals 5, same thing, no units. Okay, so maximum acceleration, just keep in mind your absolute max, absolute min. It comes back to those f prime, f double prime graphs, right? All right, last example. The velocity of a bug moving along the y-axis is given by the equation v of t equals x squared times f of x. A table of selected values of f and f prime is below. Is the bug speeding up or slowing down? So those are your keywords there, right? Speeding up or slowing down. Speeding up means that velocity and acceleration are going to have same sign. And slowing down means that they're going to have different sign. When I say different sign, I mean one's positive, one's negative. So we have to figure out at x equals 2, what is the velocity and what is the acceleration, because then those signs are going to tell me if it's speeding up or slowing down. So I have the velocity function, so I could just plug in v of 2. So I have v of 2 is 2 squared, f of 2. Well, f of 2 is negative 1, so this is just 4 times negative 1, which gives me a negative 4. So velocity is negative. So now let's see what acceleration is. In order for me to find acceleration, I'm going to come over here. I'm going to have to take the derivative of velocity. So this, notice, is two functions put together. So that's a product rule. So I'm going to have the first times the derivative of the second plus the second derivative of the first. And substituting in my a of 2 now, I have 2 squared is 4 times f prime of 2 plus f of 2 times 2 is 4. So my f prime of 2, looking at my table, f prime of 2 is negative 4 plus f of 2 is negative 1 times 4. So that's going to be negative 16 plus a negative 4. So acceleration is also negative. So since both of them are negative, this must be speeding up. So what's my justification for that? The bug is speeding up because velocity and acceleration have the same sign at x equals 2. Notice that I still use my nut there to make sure that I'm giving you the time that I'm looking at, right? So the bug is speeding up. I gave my justification, but I'm telling you that what time it's actually speeding up at. Okay, so that's important there. All right, PVA needs lots of practice, but once you get familiar with these STEM words, these important words that we went over in the beginning, these problems will come a lot easier. So you really need to make sure you know what each of those words mean and what it would mean for the next function.